We're going to have a few things handy while we work. We're going to have our completed unit circle handy to look at, even though we're working on memorizing it and we're going to be expected to have it memorized. While we're learning how to do these problems, it's just nice to have one right there to look at to make sure that we're pulling the right values and using them correctly. So you're going to have a unit circle completed handy. And let's get started. Okay, so the first thing they want is the tangent of our angle here, which is 60 degrees. So we want the tangent of the angle. So I'm thinking in terms of x, y, and r. I know tangent is y over x. So I need to find where I'm at on the unit circle. So I'm at 60 degrees. So I'm thinking about, okay, there we are, 60 degrees. And what are my x and y coordinates at 60 degrees? I know that they are 1/2 and √3/2. So that's my x and my y coordinates, which means my tangent is just the y coordinate, √3/2, over the x coordinate, 1/2. And we know when our denominators are the same, we can cancel those. So it becomes √3/1. If my denominator is 1, I don't have to write it. So it simplifies down to just square root of 3. So the tangent of 60 degrees is square root of 3. Let's try that again with another angle. Okay, if we want the sine of 225 degrees, I have to first think about where 225 is on the unit circle. So from standard position, going counterclockwise, there we are, 225 degrees. So now when I know where I am, I need to think about what my coordinates are there at 225. The ones that end in 5, those are our 45-degree reference angles. Those are the easy ones. We know that they all are going to be √2/2 and √2/2, but they're in third quadrant, so they're both going to be negative. Okay, so those are our x and y coordinates. Now, what are they wanting us to find? Sine, which when we're on the unit circle, sine is our y value. So I go find my y value, negative √2/2, and that just is my sine at 225. Nice and easy when it's sine or cosine. Tangent just takes a little more work. Let's keep going. Okay, so let's find the sine at 90 degrees. Now 90 is a quadrantal angle. So these points, I'm going to have their coordinates memorized or be able to quickly think of what they are. That's going 0 in the x direction and up 1 unit if we're on the unit circle. Sine is still y/1, or just the y value if we're on the unit circle. So I go find the y value, and that just is my sine at 90 degrees is 1. Okay, let's try cosine of 150 as our next one. So first the question is, where am I on the unit circle? So from standard position, I'm going counterclockwise. I'm in quadrant 2. And then what are my coordinates there? So I'm thinking about my unit circle at 150. My coordinates are √3/2 and 1/2 because it has a 30-degree reference angle, but we're in quadrant 2, so my x is negative. Remember, in quadrant 2, x is negative and y is positive because we're going backwards and up. Okay, now cosine is, when we're on the unit circle, only when we're on the unit circle, the cosine is the x coordinate. So I'll just go pull my x coordinate, and that is my cosine value, negative √3/2. Okay, so once we know the unit circle, we're going to be able to knock out these problems really fast. So that's one of the reasons we want to have it memorized. So it's nice and easy to do. Let's keep up the good work and try again. Okay, so cosine of 90 degrees, again, that's a quadrantal angle. I know my coordinates at 90 are 0, 1. They want the cosine this time, which since we're on the unit circle is my x coordinate. So the cosine of 90 is 0. Tangent of 240. Now tangent, remember, is y/x. So I'm going to have to use both my x and y coordinates. 240, I'm over in quadrant 3. I know my coordinates there are negative 1/2 and negative √3/2. Everything's negative in third quadrant. It's negative, negative in third quadrant. So my y coordinate is negative √3/2 over my x coordinate is negative 1/2. Remember, when our denominators are the same, they cancel. Now, a negative over negative will also cancel, so it leaves me √3/1. If my denominator is 1, I don't have to write it, so that simplifies down to √3. Now, some people like to memorize their tangents because they simplify to the same numbers every time. If you want to, you can certainly memorize those as well. Okay, let's look at 135 degrees. Remember, all of them that end in 5, those are my 45-degree reference angles, so I know their coordinates are just √2/2 and √2/2. but we're in second quadrant, so I know my x is negative. I'm going backwards and up, so x is negative, y is positive. We want the cosine. Cosine is just my x value when we're on the unit circle. And remember, I just want you to think about that. When we're on the unit circle, you have those x, y. You want to think of it as cosine theta, sine theta. And my little rainbow pin's a little distracting there, but that's the magic. Cosine theta, sine theta. X is your cosine, y is your sine. So that's just going to be negative root 2 over 2. Easy peasy once we know our unit circle. So make sure you're working on both memorizing it and keeping that in your head. Let's try the next one. Okay, we want tangent. Tangent is y over x. That's right, y over x. And so at 150, what are my coordinates? Well, I'm here in quadrant 2. That's a 30-degree reference angle. So that's going to be the root 3 over 2 and the 1/2. But we're in quadrant 2, so my x is negative. Now, so when I plug those in, my y coordinate is 1/2. My x coordinate is negative root 3 over 2. And then we just want to simplify our fraction. So we know that when the denominators are the same, they cancel. That gives me, I'm going to move that negative to the numerator just so I don't lose track of it. Remember, your negative can be in the numerator, denominator, or out front. Now, the only problem with this answer, negative 1 over root 3, is that we want to rationalize our denominator. So we're going to multiply by whatever is under the radical in the denominator. So if it has a root 3 under the radical, I'm going to multiply by root 3. But what I do to the denominator, I have to do to the numerator, so that I'm really multiplying by a well-chosen form of 1. Anything over itself is just 1. So I'm not changing the value of the fraction, but I'm totally changing its appearance. Root 3 times root 3 is 3. Okay, negative 1 times root 3 is just negative root 3. When the coefficient's 1, you don't have to write it. Okay, so that simplifies to negative root 3 over 3. So tangent on the unit circle is going to be root 3 over 3, or it's going to be root 3 when we have, or it's going to be 1. Or negative 1 or undefined. So we'll go through, and like I said, if you want to learn your tangents and memorize them, you can. It's quick to just find them like this too as well. All right, next page. So on these first few, they just have them drawn out for you to help you learn the idea. And then we're going to go through a bunch together where they're not already drawn out, but we're going to still think of where are they and how to find their coordinates. 270 is a quadrantal angle, so I can just think about where it's at. So it's not going forward or backwards, so its x coordinate is 1, but it's going down 1 for the y coordinate. So there's its x and y coordinate. They want cosine. We're in the unit circle, so cosine is my, and again, I like to have it written at the top of my page so that I can remember. It's just cosine theta, sine theta. X is your cosine, y is your sine. Okay, so we want cosine, so we want the x coordinate. So there it is. It's just 0. The cosine of 270 is 0. Okay, tangent is y over x. So you have to have them memorized in terms of x, y, and r so you know which one you're looking for. We're at 225, so I know my coordinates. All of them that end in 5 are the 45-degree reference angles. That's root 2 over 2 and root 2 over 2. But we're in quadrant 3, so everything's negative. In quadrant 3, both x and y are negative. Okay, so that's going to be negative root 2 over 2 over negative root 2 over 2. Negative over negative cancels. Anything over itself simplifies to 1. Root 2 over 2 over root 2 over 2 just simplifies to 1. So that's positive 1. Our tangent's positive 1 at 225. What about, okay, so now we're going to switch to the next video to go through the rest without the pictures already drawn, but we're still going to follow that same process.